Hey everyone, welcome you to this video. In today's video, we are going to discuss about one of the loss function, which is hinge loss. So you must be knowing what is loss function, right? So in a short, if I wanted to define loss function, it is nothing but it measures how far a predicted value is from its actual value, right? So when model makes some prediction, so we will see or we will measure how much the predicted value is deviating from the actual value, right? So that is defined by the loss function, right? So we basically calculate loss function to determine how the model has performed, right? So in general, if you see, we have a general loss function which is just actual minus predicted, right? But apart from that, we have many other loss functions. Okay, so one such function is hinge loss. So hinge loss is basically used for calculating the loss function for a maximum margin classification model, such as support vector machines. So in support vector machine, if you see, or in specific, let's say support vector classifier. So the support vector classifier aims at giving a hyperplane which has maximum marginal distance, right? So that it can segregate the data points properly, right? So if the marginal distance is more, then it can classify the data points properly, right? So it aims at increasing the marginal space. So for such model, you can use this hinge loss for calculating the loss function. Okay? So let's see how this hinge loss is being calculated. Okay, so it is calculated by, it takes a maximum of 0, 1 minus the actual value into the predicted value. So here y is the actual value. And f of x is nothing but the predicted value. Okay. So there are two things that is considered by this hinge loss. So if I wanted to calculate the loss function, what I will do, let's say if it is a classification model. So I will see how many misclassifications are done, right? But this hinge loss takes two things into consideration, okay? So it gives you the loss by taking two things into account. So one is that it will see whether the observation, that is the testing point, is properly classified or not. And it also checks the distance between the observation and the decision boundary, or you can say as hyperplane as well, is maximum or it's large enough. So what do I mean by this? So let's say we have a support vector classifier. This is a hyperplane we have. And let's assume this is a marginal lines. So let's say we have two different classes. Okay. So now assume that there is one data point, a new data point here. So now if you see, this is properly classified. Okay, this actually belongs to blue and it is classified into blue class only. But though this is a proper classification, the hinge loss is going to be greater than 0 because the distance here between this observation and the hyperplane is very, very less, right? So in this case, the hinge loss is going to be greater than 0. So when we have a correct classification, by considering both the conditions, we say it as correct classification. The hinge loss will be 0. Okay. But for this observation, if you see, even though it is properly classified, okay, you're going to have hinge loss greater than 0 because the distance between this observation and this hyperplane is very less. So basically, if you observe, this data point is coming within this marginal lines, right? Hence, it is going to penalize this data point for this classification. Okay. So if you see, even though we have a correct classification, it also checks how far this observation is from the hyperplane. Okay. So let me show you a graph here. So this is the penalty. This is the penalty size. So let's have it as 0. And let's assume here we have a correct classification. So this is the expected marginal distance. So this much distance should be there from the hyperplane. So here, let's say we have misclassification. So assume here there is one data point which is correctly classified, because as you can see, this data point comes here in this side, right? So all the data points which are going to be here are correct classifications, okay? But if you see the distance, so let's assume here this is the distance. This is a distance from boundary or from the hyperplane, okay? Now, any data points that comes below this line, okay, which is considered as less distance from the decision boundary. Okay, so for this, the hinge loss will be more. So if you see, whatever data points that are going to come here are correctly classified and the distance from the hyperplane is also maximum. So in this case, if you see, the hinge loss will be almost 0. But from here, if you see, it gradually increases. So if you see, the hinge loss will increase linearly. What is this specifies? So this is the hinge loss. What does it says? If you see, for all correct classifications, right, which comes with enough marginal distance, right, for all those classification, the hinge loss is almost 0, right? But when the distance decreases from the decision boundary, even though for a correct classification, you can see the penalty is increasing. The hinge loss increases, right? And for all the misclassifications, you're going to have more hinge loss, right? So this is what the hinge loss is. So basically it considers two things. So to calculate the hinge loss, we are going to see whether the observation, whether the new data point is properly classified or not, right? Classified, let me say it as properly classified, properly or not. And the distance between the observation and the decision boundary, whether it is maximum or not, whether it is large enough or not. So these are the two things that are considered for calculating the hinge loss. Thank you.